we have this cwisplanning.com. This is the platform that holds the tool, or this is the website that holds the platform. And you see here the resources and learning, which you would be able to, from which you would be able to download some of the tool guides, data manual, and other learning briefs. So here, CWIS SAP tool is, you have to click on this button. So now for going into the tool, anyone interested can sign up, and we are happy to set up a user and a password for this. So this works on the principles of setting up an account, and from there you have a separate account using your email ID and a password. Once you sign in, so I'm using an email address that I've already set up for this purpose and for TA Hub's purpose. And now I sign in. So once I sign in, you would be seeing a city management page. Here, see a city management page. We can set up as many as levels, or according to the user access, and the user logins will be based on that. So here, as the TA Hub logs in, they can provide user permission login to each of their DFIs, say namely AFDB, or it could be ISDB, or any other cities that they would want to. And this is a restricted access only to their particular data. So, but TA Hub would be able to look at all the other DFIs data that they have given permission for. So now, we have a pre-filled city, which you may remember from the past presentation as the day before, called as Sim City. So I'm going to go into the Sim City tile, and you would be seeing that there is a population. The city has a population of 350,000, and the population is divided into the 30% of low-income households and 70% of the non-low-income households. So this is an input that we have provided already. We can also see who has updated. We can also see who has updated and when was it updated last. The city details can be filled. Once you go here, the city details can be filled in using this tab. Here, I fill in the city name or the service area that I want to work on. Yes, there is the currency for which I'm making an assessment with. So here I'm making a SIM dollar, and the current population, the population growth rate, the inflation, and also we have the tool projects for a 10-year period. So we can choose a baseline year from which we want to make assessment, and there is a target year by which we want to reach our goals. The target year can be any year within the 10-year projection period. So you can define the baseline period and the baseline year and the target year. We also describe the average household size. Here we fill in the low-income household, the proportion of the population that are in the low-income households and the non-low-income households. And there is also an affordability benchmark, which is a median disposable income that can be spent on sanitation by these households. And as of now, this is an internal reference to guide tariff changes, and it's optional. So once we fill in the city details, we are good to go, and we can go back to our city management page, and we land into the city tile. So from here, again, the drop down of edit scenarios, and we start by selecting the edit scenarios. This takes us to the input section. When creating and entering the input for the first time, we will have only the baseline button here, you see. And we can add scenarios as we complete the baseline by using this add scenario button. What happens? This will copy the baseline and fill the data for 10-year period. So scenarios are the user-defined changes from the baseline to achieve a particular target. As you see, the scenarios are stacked in horizontal scroll as we create them. Also, there are a couple of features in this page. Say, for example, you can edit the scenario name and description once you create, or you can delete a scenario. You can write down notes and assumptions for a particular section. And also you have a data tip that is all along for guiding on the data input columns. Here you see a left navigation bar that takes us to a particular entry point under the scenario. So if I am in a baseline scenario, if I navigate to any of these, this means I am entering for the baseline scenario, right? So as we see here, we move from a defined sanitation system to defined service model, and then we go on describing the different parts of this from value chain, sanitation value chain. So the tool also allows you to skip any of this section that may not be applicable to your city. I'll come to that in a minute. So when we are describing about the defined sanitation system, we define how the coverage of the city is mapped along the value chain from toilets to reuse. Now we are in the toilet section and it's highlighted. The system flush, pour flush, and slab type of toilets are checked in for the city, and we have entered the broad toilet cost and the water requirement. Now we move on to the next section of this. Next page, the containment. The containment or the connection allows you to enter a percentage of population of your city that are having a particular type of category, hardware category, such as conventional sewer, non-conventional sewer, safe on-site, and unsafe on-site. Here you see safe on-site has lined pits and tanks, and the unlined pits are categorized as unsafe here. So this is entered for both, for the total of LIH and LIH. When we move to the emptying and transportation, we have broadly 3 types of emptying methods. That is the vacuum truck, the manual emptying with mechanized equipments, and the manual emptying with buckets and shovels. There is also an option to enter the what percentage of your emptying is being transferred through a transfer truck. So when we go to this section, what do we enter? We enter what percentage that is emptied from each type of containment is being emptied by a specific type of hardware. So what percentage of my line pit latrines are being emptied by a vacuum truck clutch? So similarly, I go on in filling for the other emptying hardware as I have in my city. So here there is no vacuum truck small and I have not filled for it. Right? The transfer trucks, and in the transfer truck section, you enter the percentage of your emptying that is being transported. Then we move to the next section, that is the treatment section. Here, where and to what extent the emptied and transported sludge is deposited in either of these wastewater or fecal sludge. And this is by the containment and also broadly by the emptying and transportation technology. Please note that this is up to the user to define if their WWTP can take in the sludge or not. And that's why we have this option of safes on-site also depositing to a WWTP. Lastly, if there is a reuse, then what percentage of treated sludge reaches the reuse from either of these wastewater or fecal sludge treatment plant is entered. So if a particular hardware is not available, say for example, a non-conventional sewer is not available in the city, it can be skipped. So far, we have successfully defined what is the baseline with respect to what type of containment and what percentage is being served along the sanitation chain. Now, going further, we would be seeing who provides the service and in this as a service in the defined service model. So this is also arranged as a part of your value chain and flows from containment to reuse. Here, this section is arranged in such a way that we have options to choose, such as households or utility finance, say for example in a containment section, or if you move to an emptying and transportation, again we have who provides a service like unregulated or regulated, or is there is a coexist of all of these, and if there is a utility presence. So also this mapping allows us to define who provides the service, and also in the tool, the respective number of the hardware, capex, opex, and price charged with respect to this service provider. Now, after defining the sanitation system and who provides the service for the entire value chain, we move to the section where from containment to reuse, it's arranged in a certain way that it is very similar in each of these categories. So I will move on to the containment, and there is a conventional sewer. If you see here, all of the data that is asked are based on the hardware details, demand details, capex, opex, and source of finance. And this is going to be similar up to the reuse section. Now let's go to the hardware. In the hardware, we are defining the units or the total length or the number of pumping stations, so on and so forth, that is particular to that type of level of coverage. Here for the baseline, you would be filling up yearly data, that is that year's data. But when you are adding the scenario and projecting, that is when you are replicating, these could be filled for the 10-year period, and the user can choose to modify in specific years as they deem fit. So the demand section is the price or the tariff that is charged. So here we have multiple tariff models. Here we are taking the sewer connection, and there is conventional sewer, and there are different tariff models and by the connection type. So low income, non-low income, and so on and so forth. Once we define the demand, we also have the capex. The capex are arranged in terms of per unit cost. And this can be used in computing the capex as we enter additional hardware in the above section that we did. We also have a place for adding extraordinary repairs and depreciation as well. The opex, the operating expenditure, has both current and ideal or optimal cost. And the source of finance is bifurcated between own funds, grants, equity, loans, and rate of return. So all along the different sections or the hardware type, you would be seeing a similar input section. Now, as we finish the baseline from containment to reuse, we will move to the last section and arrive at a place called compute. Remember one more thing is, as and when you enter a data, you may want to press next to record the data when you're moving to a page and then get compute. So now I would be going to the reuse section. I have filled the baseline and coming to the last section where I'm going to do a compute. So once I compute, we would be landing in the systems view page. I'm sure you would be remembering from a last session, the dashboard, or what we call the systems view of the SimCity. So this system view enables to compare how the city performs across equity, safety, and sustainability. And we can choose to deep dive into any of those aspects, and I have additional KPIs and capture trends in these tabs. So now we are in the system view. As we see, the scenarios are arranged vertically as we create them, and their indicators are arranged horizontally to either compare within the scenario or between them. And we also have these question marks that can be used as a guide for specific metric. More info on the specific metric. Here, the results are presented along the 4 major sanitation categories that we had input on. That is the sewer, non-conventional sewer, safe containment, and unsafe containment. Also, you will see that the visuals are presented for both low-income and non-low-income households. While blue represents the low-income households, and pink represents the non-low-income households. Let's move from left to right. We remember that in the baseline, we had a sewer length of 132 kilometers, a small amount of simplified sewers, and 2 WWTPs and FSTP as well. So, and the rest of it were on site. We noticed that this city has got 25%, about 25% access to sewer, of which 24% are serving the non-low income household, while the majority of the low income household, that is the blue bar, fall in this unsafe containment. This is used to understand the safe coverage and who gets served by which type of hardware. Also, the safe coverage is arrived based on the service level at each level of the sanitation chain that we had entered in. So now the market structure. This straightforward represents the authorities that have legal mandate in each of these sections for the hardware along the sanitation chain. Again, remember, U represents unregulated, R is regulated, and U plus R means coexist. So we may recall that we have specified these in the service model in the input sections. In the equity indicator, when we come to the equity indicator, we have a metric called the public expenditure. This public expenditure includes capital and operating expenditure over the 10-year period. This metric shows the quantum of the expenditure that is spent on each category and the household type. In the baseline, we see that most of the expenditure is on the sewer network to operate and maintain those 132 kilometers that has already been laid. While this indicator depicts the equity in the public expenditure, the cost coverage here, what we have, shows how much of your operational revenues, that is the direct and indirect revenues, covers your operating expenditure over the 10-year period. The net profit or loss you see here is the revenue minus cost, while R by C is the ratio expression of the same. The minus indicates a net loss. So if you are at 100%, it means you would be breaking even, and above or lesser 100% means you are making a loss. Here in this, we are presenting the net profit or loss for across each category. This is only utilities cost coverage. The cost coverage shows if the utility needs here additional support to operate and to what extent. Here we see as minus 42.37 is required to be sustainably operate sustainably over the next 10 years. So the other equity indicator we have is the price paid by the household. This is represented for each category and is influenced by the factors such as what is the relative presence of each type of hardware within that category, say line pits, septic tanks, and what percentage do they have, what frequency that they empty, and who they choose, what kind of technology that they choose, and by the service provider, like who provides the service. Here we see that in this case, it's interesting to see that we see on an average, the household that are served by unregulated private providers here pay much higher than the sewer households. And no wonder the cost coverage is negative to the extent of about $40 million, while the sewer tariffs are still low. So straightforwardly, the water requirement is the total amount of water required per year to use or run the specific superstructure. And we also have a safely managed, which shows the safe percentage across each of these value chain. Now, with this understanding of the indicators and what they measure, we can look into a scenario where we have made an additional investments, hardware investments. And what we have done is in the hardware investment scenario, the 132 kilometers becomes 180 kilometers, and we add 2 more WWTPs and 1 FSTPs. How do we do it? We go to the edit scenario page and change the coverage, and we'll go to it when we, I would explain it in a minute. So we would change three data points. One is the coverage, that is what percentage of your households are moving to sewer coverage. Here it moves from 24% to 34%, so a 10% increase in coverage, and a relative hardware. So there is 180 about 48 kilometers are added and 2 WWTPs are added, and that's it. And you run the model. So once you have it here, you see that with the addition of a sewer investments or even a WFSTP investment, so mainly focused on hardware with no change in the market structure or tariff, the public expenditure is still skewed and is ballooning, and it is mostly focused towards serving the non-low income households. Rarely there is an increase in the safe on site, and also which to the low income households. Even with the increased number of connections, we see that the net profit or loss for the sewers are in the negatives. So we see here from minus 42.37, it has increased to minus 56.81. So here at the same time, what this shows is that there is a possibility that this household tariff can be increased, or it shows the utility to a leeway on what percentage or how the sewer tariff can be increased or modified to the non-low income households or the institutions, and increase the or improve the cost coverage. So let's go into the tool. So this can be done. So when I know that there is a possibility to increase the tariff, I go to the edit scenario and select this specific scenario, and in the containment where my prices are specified in the demand section, and I would be interested in making this 2.5% or 2.5 times of the tariff that they have been currently paying, and this is 0.36 per meter cube. I'm going to increase it to 1.0 meter cube for the industrial as well as the institutional, and see how does this improve my cost coverage. So again, I go to the reuse section, which is the last page of the input, and then press compute. And in a couple of seconds, you would see how the tariff paid by the average household expenditure for the non-low income households have increased, and we have broke even, and also making a little more profit.
A surplus, yeah. You're actually gone.
So we have gone to a surplus scenario. So this is one of the levers that we would be interested in. Right? And also we would be interested in showing detailed OS sessions for using the tool hands-on.